Okay. Guys, last time we did a short introduction to matrices. Okay, matrix, that is singular form, matrices, it is plural form, as you know. So some special matrices. We are going to have a look quickly at these things maybe one more time. All right, so when we say special matrices, number one, now you should know that when we say matrix, we mean that it is a rectangular array of numbers, right? The numbers, they are written in rectangular brackets, right? It has rows and columns, right? And we also learned, studied how to add and subtract two matrices, and also how to multiply a matrix by a real number. And today, actually, we will focus on two things. Also, we will see some examples about this addition, subtraction, multiplication of a matrix by a real number, and also multiplication of matrices. And this 9.4, 9.5, we will see if we have time. And maybe if you don't have time, tomorrow I will have some class or next week about use of matrices in solving everyday life. So, these are some examples for matrices. And when we talk about matrices, and also its dimension, order is important. When we say order, we mean the matrix has how many rows and how many columns, right? As you see in this example, to determine the order of the matrix, just we need to count the rows and columns. As you see here in this matrix, there are 2 rows and 2 columns. So this matrix is, what is it? 2 by 2 matrix. How about this one? It has only 1 column, 1, 2, 3 rows. Always you have to write the number of rows first. So it has 3 rows and 1 column. So this is a 3 by 1 matrix, right? And how about this matrix? It has only 1 row, right? So it is 1 by how many columns? 1, 2, 3, 4. So this one is 1 by 4 matrix. All right. So and also we call this row matrix because it has only 1 row, right? And how about this one? Here we have how many rows? 1, 2, 3, right? So it has 3 rows and 1, 2, 3, 3 columns. So this is 3 by 3 matrix, right? And also actually if the number of rows is equal to the number of columns of a matrix, then also we call this a square matrix. And also actually these are very special matrices. Okay, so how about here? Samnang, can you hear me?
Yes, sir. I can hear you.
All right, very good. Okay, so here, how many rows? 1, 2, 3. So it has 3 rows and columns. 1, 2, 3, 4, 5. So this is 3 by 5 matrix. Okay, this is just how to determine the order of the matrix. How about this thing? It has 2 rows, 1, 2, right? The first row, the second row. So it is 2 here. How many columns? It has only 1 column. So it is 2 by 1 matrix. And also we know that if a matrix has only 1 column, we call this column matrix. Column matrix, right? And this one is row matrix. And this one is square matrix, right? And this one is also column matrix, square matrix. How about this one? Nothing, it's just a matrix. All right, continue. Row matrices, and also we have already studied this, a matrix which has only 1 row, it's called row matrix. These are examples for row matrices. And how about column matrix? A matrix which has only 1 column, and it is called column matrix. This is only 1 column, so it is 1 column matrices. And if we determine the order of the matrix, we know that this one is 2 by 1 matrix, this one is 3 by 1 matrix, this one is 4 by 1 matrix. How about these things? It is 1 by 2 because 1 row, 2 columns, 1 by 3, 1 row, 3 columns, 1 by 4, one row and 1, 2, 3, 4 columns. Okay. How about square matrix? One more time, we know that if the number of rows is equal to the number of columns of a matrix, then we call this a square matrix, right? So here, 2 rows and 2 columns. So that is a square matrix. And how about this one? Only 1 row and 1 column. That is also a square matrix. How about this one? 3 rows and 3 columns. That's also called square matrix. How about in this question? It is 1, 2, 3, 4, 4 rows, 1, 2, 3, 4, 4 columns. So that's also a square matrix. When we just say square matrix, we know that the number of rows is equal to the number of columns. And actually, they are also very important. That's why it deserves to have a special name. How about zero matrix or null matrix? If the elements of or entries of the matrix, all the entries are equal to 0, then we call this zero matrix. For example, here all the entries is equal to 0, and usually we can use letter O to denote this, or just bold 0. This one is bold, face 0. Okay, that is zero matrix. And also this is also zero matrix. And also actually with this, I can write here bold face 0. Okay. So here we have bold. All right. So actually, when you just say bold, if I don't have this part, this matrix may have any dimension. It may be a zero matrix whose dimension is 1 by 1, 2 by 2, 3 by 3, 2 by 3, 4 by 1, anything, right? So these two things are depending on the context. Sometimes if they just say it is zero matrix, you can just give the dimension yourself, all right? Anyway, we'll see this in this example. This is also another example for zero matrix because it's 1 by 1. All the entries are equal to 0. That's why this zero matrix. It is column matrix. All the entries are 0. That's why we call this zero matrix. All the entries are equal to 0. That's why also this is example for a zero matrix. Simply zero matrix or null matrix is the one whose all entries are equal to 0. Okay. All right. The last thing, equal matrices. When two matrices are equal, simply actually if they are exactly the same. Exactly the same means their dimensions are equal, the same, and all their corresponding entries are equal. Then we say that two matrices are equal. Okay. So conversely, if A is equal to B, then A and B are of the same order. Because if we are said that two matrices are equal, immediately we can draw these two conclusions. The first one is their orders are the same, and second one is all of their corresponding elements are equal. Okay. Example for this, for equal matrices. For example, let's say 3, 5, 1, 2. Right? This matrix is equal to 2, 5, 1, 2. Right? Why they are equal? What is the dimension of this matrix? 2 by 1. And how about this one? It is 2 by 1. I mean 2 by 2, 2 by 2. All corresponding entries, right? This entry corresponds this entry. They are equal. This entry corresponds this entry. They are equal. This entry corresponds this entry. This entry corresponds to this entry, right? So that's why all corresponding entries are equal and dimensions are equal. They are equal. But how about these two matrices? Let's say matrix A is equal to whose entries are 1, 2, and matrix B, let's say it is 1, 2. I don't have to write here, right? So now if you check this, the first entry is 1, 2. So here we also 1 and 2. Are these two matrices equal? They are not. A is not equal to B. Why? Because this matrix is, what is the dimension of this matrix? It is 2 by 1. And how about the dimension of this matrix? It is 1 by 2. 2 by 1 and 1 by 2, they are not the same. So their dimensions or their orders are not equal. That's why these matrices are not equal. Okay. For two matrices to be equal, they must be exactly the same. Same means all corresponding entries are equal and their dimensions or their orders are equal. Okay. Another example, how about, let's say the C, matrix C, it is 1, 0, 0, 1. For example, matrix D, it is 0, 1, 1, 0. Are they equal? Also, these two matrices are not equal, right? Why? Because here, this entry corresponds to this entry. So these two entries are not equal, right? The corresponding entries are not equal. That's why these two matrices are not equal. For two matrices to be equal, they must be exactly the same. So all corresponding entries are equal and their dimensions must be the same. Okay? All right, example for equal matrices. If matrix A is given by these entries, it is 2 by 2 matrix, entries are 20, B, C, 16. And B for A plus 3, D minus 4, and D. And also it's given that A is equal to B. These two matrices are equal. If it is so, we need to find the values of A, B, C, and D. Okay, using the definition, since we are saying that claiming that A is equal to B, right? First, what is the dimension of A? 2 by 2. Dimension of B? 2 by 2. Done, right? So we have no problem. Now, for these two matrices to be equal to each other, their corresponding entries must be equal to each other. So if I just write these two matrices together, let's say A, it is 20. Here we have B. Here we have C. Here we have 16. Equals, on the right hand side, we have 4A, A plus 3, and D minus 4, and here we have D. Right? So, corresponding entries, here we have 20 corresponds 4A, so this 4A should be equal to 20. B corresponds to this, so B should be equal to A plus 3. C equals this, right? C equals D minus 4. And this one equals D, so let me just write the letter on the right hand side and the number constant on the right hand side and D on the left hand side. Now we need to solve this system of equations together. I mean, we have 4 equations, we have to solve them together. From the first one, A is equal to 5, right? So if I substitute here, I can get the value of B. What is B? It is A plus 3, A equals 5, 5 plus 3 is 8. Done. So how about C? C equals D minus 4 from the last equation. D equals 16, 16 minus 4, that is 12. And D is equal to 16. So if you're claiming that these two matrices are equal, then the value of A, B, C, D must be 5, 8, 12, and 16 respectively. Okay, that is one example for equal matrices. Addition and subtraction of matrices. And as we know that to add two matrices or to subtract two matrices together, their dimensions must be the same, right? And after that, we can just add or subtract their corresponding entries. So here it says that A equals this, B equals this, and C equals this. It is not A. Let me just correct this immediately. This one must be C. All right. So A equals this, B equals this, C and D. Evaluate each of the following where possible. Okay. Just give me 1 minute. Okay, just AC is not enough. I turn on my small fan. Maybe today is pretty hot. Let's continue. So we are going to practice some addition and subtraction of matrices here. And question A, maybe I should draw a line here. All right, question A plus B. A plus B equals, what is A? 2, 3, 5, 7. Still, I don't understand why I drew this kind of line. 7 plus B, what is B? Negative 3 and 5, negative 6, 1. Actually, before writing these things, you have to determine, actually, is it possible to add these two matrices together or not? From here, I know that this one is 2 by 2, 2 by 2. That is possible, right? Addition is possible for these two matrices. For example, in the question, you'll see that B plus C. B plus C, is it possible? No. Why? Because we cannot add this matrix B to matrix C because their dimensions are different, right? So that's why we don't have to do this. Before writing this thing, you have to determine, actually, you have to decide, are you going to add this or not? Is it possible to add these two matrices or not? So from here, I know that these two matrices have the same dimensions, so it is possible to add two matrices. We know that we need to add their corresponding entries. 2 plus negative 3, that is negative 1, and 3 plus 5, that is 8. 5 plus negative 6, that is negative 1. 7 plus 1, that's equal to 8. Okay, so this is the result. B, how about B plus C? B plus C, dimension of B, as you see here, it is 2 by 2, and dimension of C, 2 rows, 3 columns, that is 2 by 3. These things are not same, so that is, we just write here, not possible. All right. How about C? Well, I did C here. Okay, C. How about B? B is B minus A. It is possible because B 2 by 2, 2 by 2, and our matrix B is negative 3, 5, it is negative 6, 1, minus matrix A 2, 3, 5, 7. And that is equal to negative 3 minus 2, negative 5, 5 minus 3, that is 2, negative 6 minus 5, negative 11, 1 minus 7, negative 6. Right? How about A is done, B is done, C is done. Now question D. Here we have D. This is C plus 0. Actually, bold-faced 0 here. So what is C is equal to 0? Also in matrices, if you add 0 matrix to any matrix, if you add any matrix to any matrix, actually, it doesn't change, right? That's just equal to C. What is C? C equals this. We know the answer, so that's equal to just 2, 5, 7, negative 3, 4, 6. 2, 5, 7. Okay. And how about E? D plus C. This one is D, this one is C, right? D plus C. What is the dimension of D? It is 3 by 2. Dimension of C, it is 2 by 3. So these things are not same, right? The orders of these two matrices are not same, so it's not possible to add this. Not possible. How about F? F0, this 0 matrix, bold-faced 0 plus D. Again, if you add from the left-hand side or right-hand side, doesn't matter. That's just equal to D. What is D? D equals this. Okay, 3, 7, 9, minus 8, 4, 2. Okay. Guys, once again, here, this 0 defines a 0 matrix of any dimension. So here we have 2 by 3 matrix or 3 by 2 matrix. I can take it as 3 by 2. Here we have 2 by 3 matrix, so I'm just taking this matrix as like this, 0, 0, 0, 0, 0, 0. But here I'm taking it as 0, 0, 0, 0, and 0, 0. Okay. But how about if you are given this thing? For example, let's say here we have 0, 0, 0, 0, plus, and 1, 2. Okay. But here it is given as a matrix form. So this one is 2 by 2. This one is 2 by 1. Not same. So here it is not possible. Okay. So you should understand the use of this bold face 0 because it may have any dimension because it's not mentioned here. So if I want, I can write it as like this. I can write it as like this. I can write it as like this. But if 0 matrix is given like in matrix form, you cannot change this dimension. Okay, this one is 2 by 2. Only if you're given 2 by 2 matrix, I can do addition. Otherwise, that's not possible. Here it is 2 by 2 matrix. I know it is dimension. So here also it is 2 by 1. So it is not possible. Okay. Let's continue. Addition and subtraction of matrices, 2 more examples. So here we need to find matrix A. Here we are given matrix A. If I add this matrix to matrix A, we get this matrix, right? It is like here, let me just say that this one is our unknown matrix. Let's say here we have X, and here we are given known matrix. I know matrix B. Here we are given matrix C. And how do you solve this matrix? It is similar to our linear equation. To solve this one, I should just take this, or I should do this operation, right? X plus B minus B and C minus B. And B minus B, it is 0 matrix. 0 plus X is equal to X. So X is equal to C minus B. So using this, I can find A. What is A? A equals 13, 18. Here we have 6 and 3. Minus, it becomes minus what? Here we have 3, 5, negative 4, 6, negative 4, 6. So if you subtract this matrix from this, 13 minus 3, it is 10, 18 minus 5, it is 13, 6 minus negative 4, it is 10, 3 minus 6, negative 3. Okay. Similar way, what we have here? Here we have like A minus this one, I don't know, that is X. Here we have, let's say, C. So what we have here, A minus C is equal to X, right? So what is our X? It's B. So question B. So here we have B is equal to, it is 3, negative 2, 4, 7, 6, and negative 5. So to this side, minus 2, negative 4, 9, 6, minus 3, 4, right? Which is equal to, again, the resulting matrix will be 2 by 2. 3 minus 2, it is 1. It is 1. Negative 2 minus negative 4, that is 2. 4 minus 9 is equal to 5. 7 minus 6, it is 1. 6 minus negative 3, it is 9. Negative 5 minus 4, negative 9. All right. Very easy. Maybe you have never done this before, just you need to practice. If you studied this before, just you need to solve a few questions so that you remember what you studied before. But in the quiz time or exam time, you need to think a bit fast. That's why you need some experience. To get experience, you need to practice a few questions. Yeah, let's continue one more question. After that, you'll have a break. Okay. Multiplication of a matrix by a real number. And we know that to multiply a matrix by a real number, just we need to multiply each entry by this scalar, right? This real number means we mean scalar, right? So in question A, here we have 3A plus 2B. That's equal to 3. What is A? 3 minus 2, 1, 4 plus 2. Here we have -1, 3, 6, -5, and equals the first one. If you multiply this matrix by 3, 3 times 3, 9, 3 times -2, -6, 3 times 1, 3, 3 times 4, 12, plus 2 times -1, -2, 2 times 3, 6, 2 times 6, 12, 2 times -5, -10, equals 9 plus -2, it is 7. -6 plus 6 is equal to 0. 3 plus 12, it is 15. And 15 plus -10, it is 2. As you see here, actually, this operations on matrices like addition, subtraction, multiplication of a matrix by a real number, or multiplying two matrices together. All these operations actually they follow a fixed rule, and that's why it is possible to write an algorithm to these operations. And that's why in most softwares actually you will see that these operations are defined. Like in MATLAB, for example, you can just multiply two matrices, and also, for example, Excel, and also all these operations are defined. Maybe next session, I'll try to show you how to do this on Excel, okay, in a spreadsheet. Let's do our last example and finish the first session, and you'll have break. B, 4B minus 2A. Now let me just write directly. Okay, what is 4B? So I need to multiply each entry by 4. 4 times -1. -4. 4 times 3. It is 12. 4 times 6. 24. 4 times -5. -20. Minus, here we have 2 times 8. 2 times 3, it is 6. 2 times -2, -4. 2 times 1, 2. 2 times 4, it is 8. Right? Equals, now we need to subtract. So dot, 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 it will be 2 by 2 matrix. -4 minus 6, here we have -10. 12 minus -4, that is 16. 24 minus 2, 22. -20 minus 8, -28. Okay, that is how we add or multiply a matrix by a real number, and also we add here and we subtract. Guys, do you have any question? If you don't have question, we will continue after 10 minutes, okay? So you have break, and after 10 minutes, we will do our second session. Thank you. See you soon.